So this is from Unit 1, Topic 1, Graphs and Applications of Polynomials revision. It's the part of the test at the end of that revision which deals with bisection. So this is the bisection method, question 1. Before I actually do this table, I'll just offer a brief explanation of how the bisection method works and what it's used for. So here's a graph of the function we're given. And what the bisection method is attempting to do here is to give us an answer for when the graph has an x-intercept, or when the function equals 0, and it's this red dot here. We could easily do that on the calculator, but the bisection method is an iterative method for guessing and checking that solution. We're not actually going to find the solution. We're only going to try a few iterations and see how close we get. Okay. So to show you how we do that, I'm just going to zoom into that graph a little bit, show you a different scene, and here it is. We're told that our first guess, or our solution, is somewhere between x equals 1 and x equals 2. So they are what we call our left and right endpoints. And on the graph you can see them here. Our left endpoint is red, our right endpoint is yellow. Here's how the bisection method works. We take the x values of those two guesses, 1 and 2, and we find the midpoint. And the midpoint between 1 and 2 is 1.5. It's about here. And we find the midpoint of that on the graph, or rather we find the midpoint, 1.5, and we find the value of the graph at x equals 1.5, and we establish that it's about there. So the midpoint between our two endpoints is 1.5, and the value of the graph is about there, and that's kind of our first guess. And you can see that it's reasonably close to the actual solution, which would be here. But we're going to have another go. So that's our first guess and check. And the way you keep guessing is to choose new endpoints now. Our first two endpoints were 1 and 2, and our midpoint was 1.5. You can see from the graph that our endpoints are now going to be these two values. We're going to find the halfway point between 1 and 1.5, which is 1.25. Here it is, 1.25. And we locate the y value of that, which is about there. Now, I recognise that this guess seems to be further away than our first guess, but bisection is an iterative process where you keep choosing the halfway point. Going to go back again. Without the aid of a graph, how do you decide which becomes your new endpoint? In our case, we had a left and a right. We found the midpoint, 1.5. We found that point. And we realise that the function, that's a negative y value there, function at the left endpoint, times the value of the function at the right, this is a positive y value, that would give us a negative result. Yeah? So this y value times that y value will get us a negative. Whenever you get a negative, you choose this half in which to establish your new midpoint, not that half. If it were positive, we would choose this half. But it's negative, so we're going to choose this half. So here we go. Let's have a guess at the second one. The second guess is 1.25, and the y value is there. Okay. So what's the value between the y value, what's the value of the y value here times the y value there? Two negatives make a positive, So I'm not going to choose that section to bisect. I'm going to choose this section. So I'll do that again, right from the beginning. My first midpoint is 1.5. I multiply the y values. I get a negative. Therefore, I choose this section to find the midpoint, which is 1.25. Find the y value. Do the same process. Multiply these two y values together. Since I get a positive value, I choose the other section to find the halfway point, which is around about there, and I get my y value. And I'll do it again. Which section do I choose now? I think you can see by now that it will be that section, and our midpoint's about here. There's our point there. Which section do we choose? We choose this one again, and you can see that the more I do this, the closer I'm getting to our final solution right there. So that's a graphical approach. You're not really given the benefit of this when you're doing bisection. Really, you've just got these values here. So let's use the table. My left endpoint is 1, my right is 2, my middle is 1.5. So what do I make my next endpoints? Do I choose these two, or do I choose those two? You make the choice based on the sine of f of a times f of m. In this case, it's negative. Because it's negative, our new midpoints, as I've shown you on the graph, I'll just rub out all of these, as I showed you on the graph, it's going to be this section. One way we show that is like this. We put a 1 there, that stays there, but this midpoint becomes the right end point. And we find the midpoint between 1 and 1.5, 1.25. Now we have to work out f of a times f of m, and we'll do that on our calculator. F of a, which is f of 1, times f of m, which is 1.25, gives us, oh, we don't need standard, we can work it out in decimals. We get a positive number, which means, let's go back here, we get a positive number there. That means the midpoint is going to go that way. So this is now 1.25, and that stays the same as 1.5. What's halfway between 1.25 and 1.5? There's no reason why you can't use your calculator to do that. It's basically 1.5 and 1.25. 1.5 plus 1.25 divided by 2 gives us 1.375. 1.375. Now we want to do f of a times f of m. Let's do that. F of a, f of a times f of m. I don't think that's m. Hang on, I need to go back and check. Yeah, it's 1.25, 1.375. 375. Let's see, is that positive? Yes, it is. It's positive, so we do the same process because it's positive. That midpoint goes there. We get 1.375 and 1.5, and now we want the midpoint between those two. We can use our calculator to do that, and we get a midpoint of, what am I doing? It's in here, 1.5 and 1.375. There's our midpoint, 1.4375. 1.4375. Now, It doesn't matter what the f of a times f of m is in this case, because we're only asked to do it for 3 further iterations. There's 1, and here's 3 more. There's the 3 extra iterations. And the final solution, when we kept finding the midpoint, was this value here. That's the final solution. 1.4375.